Hello. So in this tutorial, I'll be showing you how to make swirly smoke action in Houdini using custom velocity vectors and directions. So let's get started. All right. So we'll be importing a mesh and generating some normals. And next up, we'll be going on ahead and generating a point cloud basically. So we'll be encapsulating the mesh within a box and scattering points inside it so that we can generate a velocity volume later on. And we need to transfer those normals which we made in the previous step to the point cloud. So I'll be doing that, and we'll generate a direction using the cross product. So I'll explain that briefly before we head into that. And after that, we'll be generating a velocity volume so that we can control the direction of our smoke. And then we'll be generating a smoke source so that we can tell Houdini from which parts to emit smoke from. And after that, we'll be generating a collision source so that we can contain the smoke. And finally, we'll be importing these three fields into the .NET, and we'll be making a smoke sim from that. So let's get started. Okay, so let's go ahead and add in a geonode. So we'll dive in, and let's add in a mesh. For this, I'm just going to be using this test geometry, that is the test pig. You can use any mesh you like. And I'll go ahead and add in a normal node. Right now, the normals are being generated from the vertices. So let me connect that to the normal node and change the add normals to points. So now we have normals generated from our points. Okay, so now that we have generated the normals, let's go ahead and transfer them to a bunch of points so that we can later use it for our velocity field. So to do that, I'll make a bounding box first of all. So what this is going to do is it's going to generate a box around our geometry like that. If I just template the bound, you can see exactly what's happening. So I like to increase the lower padding and upper padding just a bit to give us enough space in between the geometry and the bounding box. So that looks fine. Next up, I'll convert this into a volume using an ISO offset node. And oops, sorry. All right. And in the sampling division, let's increase that a bit so that it is more accurate. It represents more like a box. And finally, let's add in a scatter node so that we can scatter points inside the volume. Yep. I'll just disable relax iterations for this tutorial, but you can go ahead and enable it on your file. And I'll increase that to around 100,000, but I suggest you go even further if you want more accurate velocity fields later on. So okay, now that we have our points, if we middle click on the node over here, we can see we only have one point attribute, and that is the position. So we need to transfer the normals from our pick head to the scatter points. So to do that, let's add in an attribute transfer. And we want to transfer to the scatter point. So I'm going to connect that to the first input, and we want to connect the normals to the second. So okay, we can see something's happening already. I'll just go disable primitives and just type n over here just to make sure we are only transferring normals in the points. And let's go to the conditions tab and reduce the distance threshold first of all a bit, so that we can see what's going on. So you can see that actually, you know what, let me reduce this a bit so that you can see. So you can see that the normals got transferred to the scatter points. So that looks fairly nice. And what I like to do is I like to increase the sample count. It just gives a more accurate result. So let's give that to 20, and I'll just dial this back up like so. And the distance threshold you can play around with. If you're unsure that your velocities will get picked up, you can always increase it to maximize your coverage. But for now, I'll just leave it at 0.1. All right, so let me go ahead and explain in brief what a cross product is. So it's just basically the multiplication of vectors. And for this, we need two vectors. So the first one is going to be colored in blue, that is the normals. And the second one is our red vector, that is a constant. Now we'll set this up in the next step. That's easy to do. So the blue one is our normals and the red one is our constant. Now it's also being generated here. If I just go into the wireframe, you can see. So using this, we can generate a cross product. So depending on if your value is positive or negative, the cross product is going to be in the direction that is perpendicular to the red and the blue vector. So over here, let's say, let's see. I'll just enable the cross product. So we can see that it's perpendicular between the red and the blue vectors. So no matter where you see, it's always going to be perpendicular, and it generates this kind of a direction. And the angle between the red and the blue vector affects the length of the yellow vector, that is the cross product. So where the angles are much more, for example, let's say in the middle where it's almost 90 degrees between the red and the blue vector, let's say it generates a cross product vector of 1. And let's come to the sides, and we can see that it drastically is less because the angles between the red and the blue vectors are less. And over here we have basically no cross product being generated because both the red and the blue vectors are parallel. So that should explain in brief what a cross product is. Also, let me just change the direction so that you can see in real time what's happening. So you can see no matter how or where the direction is of the red and the blue vector, it's always going to be perpendicular between them. Okay, so now that you have a bit of an idea what a cross product is, let me show you how we can generate directions from it. Okay, let's add an attribute. Okay, before that, I've added this delete node over here so that we delete those unnecessary points so that we can clearly see what's happening. So I'm just going to pipe that into the attribute warp. Now, just a reminder, I'm just using this for the tutorial purpose so that we can see clearly. Just make sure you delete this if you're following along. I mean, you can delete this later, but yeah. So let's dive in. Let's add in a normalize node. So what this is going to do, it's going to normalize our vectors. Basically, if we have for some reason, a strange vector that has the length of, I don't know, 10 or something, and it's going all the way here, it's going to bring that back over here just to make sure that we have a unit vector. And let's add in a cross product, and we need a constant. Fine. And let's plug the constant into the first input, and the normalized normal, we'll connect that to the second input. And let's connect this to the velocity as well as to the normal channel just to visualize it for now. So in the constant, first of all, we need to set the type to a vector because we are working with vectors. And okay, nothing's showing up, right? So we have to set at least something over here. Everything's 0 right now. So if I set 1, you can see, oh, we have a swirly action going on. And we can change the values. So right now it's 1 on the X. Let's change it to 1 on the Y. So we get a different result. And we'll do the same for the Z, like so. So you can come up with different swirly directions. So you can also combine them and get vectors that go in a different angle. So let's keep, I'm going to keep 1 on the X for now. That's fine. And yeah, that's how you do it. Okay, so let's add in a VDB from polygons node. And we'll put that into the first input. And the voxel size, we can reduce it to 0.03. I think that's fine. And make sure the distance VDB is checked so that we can get the surface attribute. And we'll add in a VDB analysis. So the way it works is that the surface over here that you see in white, that stores a scalar value of 0. And whatever is outside the surface and within this bounding box, it stores a value of 1. And anything inside the surface over here where it's hollow, it's actually a volume that contains a value of -1. So using these values, the VDB analysis is going to make a vector direction that points from within the from the center of the mesh to the surface. So to do that, let's direct it to that surface attribute that we have over here, so that it knows that till where we want to calculate those vector directions. So make sure it's there, and the operator is set to gradient. That's fine, that's what you want. And we'll change it to custom name and call it push for now. And so that's being generated. If we just middle click, you can see that we got those directions generated over here. So we want to transfer it back to the scatter points. So to do that, there's this node called attribute from volume. So we want to transfer it to the scatter points, connect that to the first input, and the volumes that we want to read from, we'll connect that to the second. Right now it's set to CD, that is the color. Let's rename that to push, that we just generated, and make sure it's also the same in the volume tab over here. And the attribute type, it's a vector. As I said, it's converting a scalar to a vector. All right, so let me just visualize this. Give me a sec. All right, so I just added this visualize node, and it looks like that with just that. And I've just reused this delete node that we used before, so that we can delete those unnecessary points to see better, of course. So we can see that we have some vector directions that are being generated, and it points towards, outwards towards the surface. That is this. Cool. Right now it's only being generated close to the boundaries of the mesh. So in order to fix that, we want to actually make sure that the volume is being calculated from within the mesh all the way in the center. So to do that, we can go back into the VDB from polygons node. We can either increase the interior band voxels. So you can see that in the viewport, it's extending more towards the inner portions of the geometry. So that's what we want. Or what we can do is we can set that back to 3 and just click on this checkbox, fill interior. That just makes sure that our volumes get calculated from the inside as well. All right, so since we have the push vectors generated, let's add that back into the swirly kind of direction that we have. So how do we combine this both? So let's add this into the second input. And first of all, let me just delete these two, because this way just placeholders, just to visualize it better. So anyway, we have them imported right now. So to import it, to read the attributes, we need to put in this import point attribute node over here, and set it to second input, and the attribute is called push. Okay, so now we need to, let me just put that into the normal channel so that we can see. So yeah, that's what we have. And let's normalize this vector just to be sure. And we'll add in a multiply node and constant. We'll use this constant to control how much push we need. So we'll just connect that to the second input, and I'll add in an add attribute, node, so that now we can combine the cross product as well as the push direction. And I'll just put that into the velocity and the normals for now. Okay, so it's not getting combined. That's because the constant value over here is set to 0. Now if I just change that, you can see that it's gradually kind of extending outwards. I hope you can see that. You can see that, right? So we can use this to push our the smoke outwards, and it also pushes from within the geometry. So that's good. So anyway, we can promote this into the SOP level so that we don't need to come back inside this attribute warp every time. So what we can do is we can middle click on the second input and promote that, and as well as I'll promote this constant over here. So now we have those two attributes that we can play with from the SOP level. Oh, and before we go any further, I'll come back into the attribute warp and disconnect the output to the normals. We just did that so that we can easily click this button and visualize the direction. Okay, so let's go ahead and add in a pyro source. Now this node is, it doesn't do much per se, because the only thing we are doing here is we are going to leave everything at default and just click on this add button to add an attribute for our velocity volumes, and we want to generate velocity from the existing v attributes that we have over here for velocity. So to do that, let's change this from custom to velocity. So it's going to give us that velocity field, name. And honestly, in the geometry spreadsheet, it doesn't do much. It just converts the velocity x, y, and z axes into v0, v1, and v2. So it's just renaming these velocity attributes, but it corresponds to the same axis. So 0 is for x, 1 is for y, and 2 is for z. But it plays a huge part when you convert these points into a velocity VDB. So we'll add in a volume rasterize attribute. So that's going to convert these points into a velocity volume. So make sure the attribute v we have over here, make sure that's mentioned over here. So you can see that it automatically generates, I don't know if you can see that, but let me just change the background to dark. So you can see that it generates a volume. So this is going to be our velocity volume. So it's going to tell our smoke in which direction to go. Right now you can't see much, or you can't make of what's happening. So let me add in a volume trail, and I'll connect the velocity volume to the second input and the points to the first input. So you can see that we get this direction that flows in this kind of a way that we have set in the attribute warp over here. Now let me change that to one in the x-axis. So we get this kind of action going on. So the pyro source, it comes in handy. Let me disable that, and yeah, that's I don't know why that happens, but just leave that there. So yeah, in the next step we'll go ahead and put this into the DOP and control the smoke. Oh, and before we head out, I'll just add this null object here so that we can clean up our workflow a bit, and call this well. Also, I completely forgot that we have to make a collision geometry and a smoke source. So we'll be doing that first, and then we'll be moving to the DOPs. So yeah. Okay, so let's go ahead and generate our smoke source. So for that, let me just add in the pyro source. It's going to be the same workflow for how we did the velocity volumes. I'll just plug in the, I don't know where this came from, but I'll just plug in the geometry into the pyro source like that. Now you can choose either source smoke if you want to do some combustion, or but for now I'll be using source smoke only. So it's going to generate attributes automatically, that is the density and temperature. And you can either choose to keep input that's going to extract the points from your geometry and use that as a pyro source, or you can switch to surface scatter. Yeah, I don't know why it does that, but the only fix that I've seem to have found is by disabling the add shader function. So yeah, so what it does is it scatters points on your surface, but there'll be nothing inside. So it'll be hollow inside. Or you can, what I like to do is I like to keep it to volume scatter, so that the inside, so that we have basically smoke getting generated from within the geometry. So I'll keep it like that, and next up we'll add in the volume rasterize attributes, same like how we did in the previous step. I'll in over here though, I'll enter those attributes that we have generated over here, that is the density and temperature. So let me go ahead and type that in. Cool. So that's our smoke source. We can choose to reduce the voxel size. I'll reduce that 0.01. That's not enough. And you could also reduce the particle scale. Oh, yeah. Uh, you want to make sure that you have a bit more particles. So reduce the particle separation so that you get a more dense volume. Something like that is fine. And I'll just change that back to 1, the particle scale. So yeah, that's looking much better. And you can obviously go ahead and reduce the voxel size. So that looks fine. And at last, I'll be adding a null so that we can keep our workflow clean. And I'll change that to smoke. Okay, moving on to collision. This is the last step in the process. So what I like to do is I like to add in a VDB from polygons. Now there are a couple of ways of doing this. You can directly export the base mesh as a collision object into the DOP. But what I like to do is I like to put this into a VDB from polygons, and let's reduce that to 0.01 so that it's more recognizable. And I like to add VDB reshape SDF. Now with this you can dilate your VDB. So in that case, if smoke for some reason gets generated on near the edges of the mesh or maybe even outside, you can always capture those smoke and contain it within this collision mesh. And if you didn't have this dilate thing, probably sometimes the smoke would escape, so you'll have smoke escaping somewhere. So just to be safe, I like to dilate this a bit. Let's keep it at 1, that's fine. So you can see the difference, and we can put that into a null. Plug that into a null. You can also smooth this SDF if you want using a VDB smooth, but for now I'll leave it like this. So I'll just call this collision. So yeah, that's it. Let's move on to the DOP part so that we can set up the smoke and do some simulations. All right, so let's go ahead and add in a DOP network and let's dive in. So here we need to make a smoke solver. So instead of making it from the scratch, let's go back into the geo and we'll click on that. And what we can do is inside the pyro FX. So make sure you have your geometry selected in the beginning. You can either select this or this, doesn't matter. And click on the billowy smoke and click on the pig head and press enter. So it's going to be generating a pyro FX preset for us. So let's go back into the geometry section, and it has made a couple of unnecessary nodes like this. So what we can do is we can delete them because we don't need them. Also delete that and go back in the object section. It has already made this, delete that. Fine. Let's go back into the .NET. So we need to change a couple of things because we shuffled some nodes around. We deleted some nodes. So in the source object over here, we just want to source our smoke object, that is this one that we have already made. And this one, it just contains the density and the temperature. We'll be importing a custom velocity that we have made before. So I'll just delete this one over here, which came with the preset. So that's fine. We just need the density and the temperature. In the gas resize node, make sure the max bounds is unchecked. The clamp to maximum is unchecked. And in the tracking object, check that, track by object. And let's track, I don't know, any one of these is fine. So I'll track the smoke source object. So it's just going to be resizing our this bounding box correctly. And in the pyro over here, we can let's decrease the division size to something, let's say 0.05. Cool, that should be it. And let's hit play, see what happens. Yep, that's looking pretty good. Let's import our custom velocity. So for that, I'll be importing a volume source, the same as this one. So in the volume source over here, let's click on the add button over here. And instead, this time of setting it to scalar, let's set it to vector. And the source volume, let's see, what was our attribute name? So the attribute name for our velocity was v. So whatever name you have given for your velocity, make sure that's in the source volume, and the target field, set that to well. So the reason why we set that to well is because this is the default name that Houdini uses to identify it's a volume velocity. So set that to well, because Houdini. And what you can do from here is merge that with this smoke object. Oops, and I forgot that we need to direct it to a volume velocity. So click on well. Fine. And let's just increase the scale over here. So you can control the velocity scale using this slider. So let's hit play and see what happens. Let me just increase that to an insane amount, and you can see clearly. Yep, that's working. Fine. Let me set that back to 3 for now. And just one last thing we need to do is we need to set up a collision object. So for that, let me add in a static object and a static solver. So in the static object, let's import the collision object that we have made. And right now it's, remember that our collision object is actually a VDB volume. So we need to specify that it's a VDB volume and not to, treat it as anything else. So in the collision guide over here, if I just enable that, we can see that it's not really treating it as a VDB volume. So what we need to do instead of in this mode section over here, instead of re-intersect, change it to volume sample so that it knows it's a volume. And yeah, you can see we get that same VDB mesh over here so that it would treat that as a collision object. Let's just hide that. Let's put that into the static solver and merge this. And it's important to maintain the order. So we need the static object to be first and the pyro solver to be second. So you can do that by, clicking these arrows to rearrange them. And also in the static object, make sure the invert sign is checked. That's because we want the smoke to collide properly with the collision object, because we are emitting it from the inside. And that should be it. Let's go to the output section. Also, let me just disable the display geometry. And before that, just to make it more easier, and before that, just to visualize the smoke a bit more easier, because in the DOPS, you can't see the smoke very well. So what you can do is you can go back into the SOP level, add in a volume visualization, and that. And in the .NET, we just want to import the pyro, that is the smoke object. And let's mask that out by putting that in the object section. And we just want to import the density, right? And in the volume visualization over here, we can type in the same field, density, that we want to visualize. Oops, density. And I have a couple of lights set up so that we can see it. And I'm just going to be increasing the density scale a bit and the maximum values, like, I don't know, let's say 30. All right. So from here on, anything that you do would be inside the pyro solver. So I'm just going to go ahead and tweak a few settings here and there a bit. Okay, this part is kind of important. Actually, it's very important because depending on the velocity that you have set in your volume source over here, depending on that, you might have to increase the maximum and minimum substeps to get the accurate smoke result, because what it's going to do, it's going to be calculating in between frames rather than on each frame if you have set it on 1. So if you have set it on 3, for example, it's going to be calculating, I think, 3 times on between each frames. So make sure that is set to 3 or something higher. And in the pyro object, the source smoke object, I'm going to be setting the division size something low, like 0.2, so that we can get a higher quality result. And let me just hit play and see what happens. All right, so I've just let it run for a bit, for 22 frames actually. So you can see that something's happening through its silhouette. But to actually visualize it, let me just go into the .NET, and here we have 2 fields over here. So in the object over here, we need to import the pyro object, that is the smoke object, so that we can read the density attribute that we have. And we'll add in a volume visualization. So let me just put that into the first input. And in the density field, let's type in density, as well as in the diffuse field. And over here we can play around with the settings. So I'm just going to be seeing what fits the best. I'm going to be increasing the maximum to, I don't know, let's say 100. So this is how you make a smoky, swirly action in Houdini. So now if you want to export this, what you can do is you can add in a DOP import export. And in the DOP.NET, choose the DOP.NET that you have. And the DOP node, it would be the, which one was it? The pyro. That is the smoke object that's over here. So you want to export this and make sure the fields to import, you want to import whatever fields that you want. Right now, I only have density being exported from here. So what you can do is we have a couple of fields, that is the density, temperature, and also the velocity. So what you can do is you can type in density. You want density, you can type in density. You want temperature, you can type it temperature, if I can spell that. Yep. You want velocity, you can type in, I think, well. I believe it is well. Yeah, it's well. So right now it's a mess because everything's showing together. So if you want to isolate them, you can always use this volume visualization. And that way you can choose what fields you want to import and see. So that's pretty much it. Also, actually, no. You want to export this, you can add in a VDB convert. Like that. You can add in a VDB convert and plug that in over there like that. And convert this into a VDB. And in the group section over here, choose density, temperature, well X, well Y, well Z. So everything that you want to export that you have typed over here, make sure that's in the group. And that should be it. You just need to add a file cache over here. And in the geometry file over here, you can choose, let's say, and in the file sequence, you have to type in your file name. So I'm just going to be typing file $F for the frame number and .vdb. And that should be it. You should be done, and you can just click save to disk, and that will export everything. Alright, so that's pretty much it, and I hope you found the tutorial helpful. Make sure to check out the Houdini digital asset and the project files. I'll leave them down in the description below. Thank you to my patrons for the support. Get access to all the scene files and HDAs that are made so far in my Patreon. So be sure to check that out as well. Anyway, that's pretty much it. I'll see you in the next tutorial. Take care.